Hello again, welcome back to Cloud and 5G Live. Time for our next fireside chat today, and that's 5G transformation explored. A fireside chat on empowering the future with next generation connectivity. Now, this is a subject I'm sure we could fill our entire afternoon with, but we're going to try and do it in 20 minutes. It is with Chetan Kumar, Senior Director Engineering at Mavenir Systems. Thank you so much indeed for joining us this afternoon. How are you?
I'm doing quite good. How are you?
I'm very good, thank you. Very good. As I said, we could fill this this subject could fill the whole afternoon. So let's try and do 20 minutes on it. So let's start with the basics from your point of view. How do you see the role of 5G MEC in the overall transformation of 5G networks? What part do you feel it plays?
Yeah, that's really a good question to start the conversation. See, to start with, maybe I would want to go with defining the requirement, right? The why part of it. So if you look at the requirements today, both the consumers and the enterprise are looking for responses and experiences that are real time, right? That's what people really want today. And in that scenario, low latency becomes a very critical requirement for business and consumers, right? So now let's look at how the MEC is going to come into picture, keeping this requirement as a primary motivation factor. So now today, most of the applications run on the cloud. So we know that. So essentially what that means is you run your application on your mobile phones, most of the data is actually stored on the cloud, and then you probably end up consuming it. And typically, these cloud data centers are set up most commonly at a place where both the land is comparatively economical, and then low cost, less expensive power and water supply and those kind of places. That would essentially mean when you click for an application on your mobile phone, by the time it reaches the actual data center and comes back, it probably had to travel hundreds of thousands of kilometers. That would mean you really cannot get a low latency services, right? Now, the cloud did a phenomenal job in terms of it provided a mechanism for enterprise to outsource their infrastructure management. In fact, actually, I would say cloud also democratized the technology, right? A lot of small and medium enterprises could get access to the technology that were not thinkable. I mean, for example, small enterprise to get access to high powerful compute and GPU resource with limited upfront cost is what the cloud did. And that's what actually fueled a lot of business so far. Now, we are moving towards the consumer need and enterprise need, which requires a low latency service. And now, your edge computing plus 5G is what I would call it as MEC, right? Mobile edge computing are probably like multi-access edge computing. That's what MEC is all about. Now, MEC is rightly suited, the fact that we're doing an edge computing, to provide this requirement of low latency, to provide the application the required latency constraints. And that's how the MEC is going to transform the entire 5G network in enterprise.
Because I guess from a technical point of view, it can be very easy for us to get bogged down on the technical advances, the different technology that's available. How critical do you feel it is that we never forget the end user, the end consumer, and what they are wanting from the technology? Can it be easy to maybe get sidetracked and forget that if we're not careful?
Yes, absolutely, right. So therefore, as I said, the end user requirement, in my opinion, is to run applications that provide the near real-time or just the real-time services, right? That's what is end user requirement. So now, we can think of a lot of applications which people want to run from a user perspective. They may want to run a healthcare application, or they may want to run a smart manufacturing applications, right? So now all these things will finally boil down to a real-time service, right? If we talk about even today, one of the hot topic is generative AI, right? If you look at generative AI as a service, it generates a lot of data, and people are using generative AI services for predominantly general purpose services. If they want to start using it for specifics, right? If they want to use it for in industrial automation, right? That is where your low latency requirement plays a very critical role, and that is where your MEC plays a very critical role for the 5G to really pick up.
Well, let's move on to the main benefits of private networks, particularly in the context of a 5G transformation. How do you feel they give new use cases and drive innovation? Where do you see private networks fitting into that big picture?
Okay. To sort of a little bit changing gears, I mean, we're very close by, but then like your private network is essentially your general purpose or your public 5G network, public cellular network. The only difference being it is managed by a single enterprise, and most importantly, it's restrictive, right? So that's what is essentially your private network is all about. Now, the major benefits of the private network is essentially the private network helps you to develop a high reliable network, a secure network, and also helps you create a network which provides again a low latency services, right? So what really happens, right? So now, as compared to your public network, you're going to set up a network within your enterprise, managed by the enterprise own, right? And then subsequently, this network, the entire network infrastructure, in terms of the radio part of it, the core part of it, everything is going to be set up locally there, right? So that's what provides a pretty much good control. Now, we all know that 5G network is pretty secure, right? In general, cellular networks are pretty secure. Now, the same technology gets applied into the private 5G network, making it a lot more secure for users to use it. That's one of the big benefits what private network provides, so as compared to any other competing networking technology within an enterprise. And second thing is, the private network, as I said, it operates within your premise, in which case you can control the power at which you're actually generating, the way you probably want to place your radio. You get a very, as compared to any other competing technology. And third point, which I spoke about, sorry, is my audio and video okay? I'm getting some feedback here, or can I continue?
Yes, do continue. You did break up for a moment there, but we've got you back, so do continue.
Okay, good, great, thank you. And third important thing, what the 5G private network provides for enterprises is essentially it provides a very high speed and a low latency network, right? We can think of speeds in terms of upwards of 1 gigabits per second, 1 Gbps, and as well as sub 10 milliseconds latency. So within your premise, right? So now, just to summarize, because I'm going to talk about, as you said, the next part of your question in terms of application. So before getting the application, summarize, your private network provides a high secure system, a reliable and better coverage system, and provides a high speed and low latency system, right? So now keep these facts into the picture, right? Now, this is something very, very essential for any network to offer a reliable infrastructure to run your applications, right? So for example, let's take an example application of, say, AR/VR or mixed reality application, which can actually be used in a smart manufacturing scenario, right? So now essentially, you need pretty much high throughput because the amount of data which you will be sending and receiving to render 3D objects will actually be pretty huge, right? So you need pretty high speed network. And then you need a very low latency network because when you're probably reacting with the environment, it has to be very responsive, right? So now that's one of the reasons like why you need a low latency, and another important thing is obviously you need a better coverage in terms of in your entire premise, wherever you want to use your AR services, it should probably work as expected. In fact, like we had one of the case wherein in a manufacturing unit of a aircraft industry, the people would actually wear this AR headgear and then move almost like 500 to 600 meters, right? Like, so now you need to have better coverage there. So now this is one of the classic example of the smart manufacturing using AR services, which would actually benefit pretty much by your private network. And of course, we can talk of many more applications apart from smart manufacturing, like surveillance, right? In fact, to think of surveillance, right? Like, so one is you need a reliable and a secure connection to transport your video stream, right? And you don't want to sort of pump all of them to the cloud. You want to process it locally, and that's where the private network plays a very critical role. So one other example as well. Yeah,
that's an outstanding example. One thing you did touch on there that I want to dig into a little bit further is the importance of security, because it's the holy pair, isn't it? It's the speed and it's the security. For you, how big a role does security play in the next generation of 5G technology?
So how big a role is, very big. So what I mean is, so essentially the security becomes one of the key pillar when you're developing your enterprise network, right? So when you're creating your network, the infrastructure, what we are building to connect your devices, then people and things and other things, has to be a very secure system. No doubt on that, right? What we need to understand is we're not talking about a general purpose application here. We're talking about an infrastructure. Now, the infrastructure is broken. All your applications are broken. If the base system where it provides you the connectivity, if that is sort of broken when somebody tries to get access into a network, boom, like after that, like you don't have to worry about application security. You don't have to worry about database security. You're pretty much exposed, right? So that way, the security becomes the fundamental pillar of any infrastructure services, and your 5G network and private 5G network, and even MEC being an infrastructure service, security becomes one of the critical things, right? So now there are a lot of competing technologies which provide wireless connectivity, which has fairly good security mechanism, both in terms of the data encryption and then policies to authenticate the users and all those kind of things. Whereas the 5G network and predominantly the cellular network has been built ground up, keeping security into consideration. Right. So the fact which we need to understand is we are thinking of, just give you an example, we are thinking of using your cellular network to even cast your votes. Right, and there are many countries are thinking in terms of why can't I sort of cast our votes using 5G network? And most of financial transactions happens with the OTP that comes over your cellular network, right? So the entire cellular network has been built keeping 5G as one of the key pillar. And now the good part is the same thing moves to the enterprise when we create a private 5G network. So that's how the security is going to be very critical, and then that's how security will actually help the next generation connectivity in private networks.
Absolutely. We were talking earlier a little bit about the importance of edge computing. I'd like to dig into that a little bit more now, because it is so critical in the whole picture. For you, how does edge computing play that crucial role in not just the deployment of 5G networks, but the optimization of them?
Okay. Yeah. So now. Okay, so I would like to sort of explain this question, or rather respond to this question, looking at the current one of the most important technology, which is generative AI. Right. I mean, I think everybody talks about generative AI these days. Of course, it has actually given a breakthrough breakthrough services as of today. Now, if you look at your generative AI solutions, essentially there is a huge amount of data, right? And then you need to compute or you need to process that data, and then you create a pre-trained model. Right. Once you create a pre-trained model, then you're going to use that model to generate machine-generated content. That's what is generative AI. So therefore, like, you have the data, you need to create a model, train the model, and subsequently use it. Right. So now, think of this particular generative AI applications, generative AI-based applications in an enterprise scenario, for example, in a smart industry. Right, so wherein like you probably want to do maintenance or production, or even managing your supply chains, or even managing your conveyor belts, and all those kind of things in a big industry, right? Therefore, now what really happens is, like, now what this would mean is you probably will have a lot of sensors which generates a lot of data, and then you need to push all this data to the place where you're actually going to create the models, and then run your training mechanism, and then push the inference model back, and then use that inference model to take actions to generate responses, or probably like give advices to the employees or workers, right? So now, this particular scenario, what it would mean is, one important thing is you're pushing a lot of data to the cloud, right? That would mean you're actually putting a lot of load on your backbone, right? A lot of load on your pipe, which is actually connecting to the cloud. And of course, which also means you're actually generating higher cost to the enterprise because of the data that's being pushed across, right? And another important thing on top of that is you probably like going to, you don't have control on your data, like the data goes somewhere else, like who's going to use it, how people are going to maintain the data. That's again a bigger problem for that. And third important problem, I think we've been talking about low latency as one of the critical piece. Like now you need to probably get the for this particular applications to run, a generative AI application in a smart industry, a smart manufacturing to run, it probably need to give a real-time responses, right? For these two things, for these three things to happen, an edge computing platform is an ideal scenario. Right. So now the edge computing platform will make sure the data is not flown to the cloud and reducing a lot of reduction on the data on the backbone or on the backhaul network, and then giving a low latency because you're running locally, and then you're retaining the data locally in your own premise, right? So this is how I'm just giving this specific example to tell that, okay, how edge computing is going to help a lot more of 5G deployments. The edge computing is going to help a better transformation of your connected network or a 5G infrastructure.
We've covered off an awful lot of great innovations, wonderful things that are in place, that are appearing in the market already. But in terms of 5G transformation, for you, what are the key challenges that both organisations, infrastructure providers are going to be facing when trying to implement and adopt all these technologies? Because if it was easy, they'd already be doing it. What are the key challenges? Yeah, absolutely.
One of the challenge in the 5G deployment is fairly, I'm telling you, it's slightly higher on the capex, initial capex, right? I mean, the 5G technology is a little bit on a higher side in terms of the cost as of now, and until sort of the technology break even, and then like you probably have a lot of democratization for the cost to come down. That's one of the key challenge which people would face, upfront cost. And the second one being the spectrum, right? I mean, unlike other wireless technology, the 5G operates on a licensed spectrum, and then it depends on how the local policy makers, in terms of how the local government works in the spectrum and how you get access to the spectrum. Those kind of things becomes another interesting challenge. And also,
we have just lost your
happening in the, like, for example, Yeah.
Oh,
Okay.
yeah, we lost your signal just there
I
for a
can see you.
second. Yes. So yeah, if we could just return to the challenges, I think we've got you back now. Can you hear me? Okay.
So the overall. Okay.
Yeah, we have just lost your signal.
Sorry, is the network still bad?
Yeah, the network did just cut out on us, which has a certain sense of irony at this event. Can you hear me okay now?
Yes, I can pretty much hear you. I'm able to hear you very well. So just for a while, I just turn off my video.
Okay, that should see us through the last few moments.
Okay, is my audio okay now?
Yep, your audio is loud and clear.
Okay, great. So I'll just continue. So I said upfront cost and then spectrum. These are the two challenges, and then other important challenge is basically the technology is also sort of not completely mature enough as of now. There are a lot of solutions coming out on the 5G private networks, predominantly in terms of the deployment, in terms of the management and connectivity to the external entities within the enterprise network. There are a couple of other things where the technology maturity is happening. But however, like that still is a little bit of challenge as of now.
Okay, and as you say, plenty of challenges to get through. Well, we are having a couple of technical problems with your feed, so we will leave that there. But really enjoyed our conversation today. We've got through a tremendous amount there. So thanks ever so much for joining us here at Cloud and 5G Live today.
Hey, thank you.
Thank you very much indeed.